Let's look at a second example of linearizing data. So once again, we're asked to make a scatter plot of the data, then linearize the data according to the given model, graph the linearized data, and find the linear regression equation. Then we use that linear regression equation to transform the data, find a model for the original data. Now this time, as last time we were looking at a quadratic function, at the quadratic data, now we're looking at a logarithmic model. And the logarithmic model is such that y is equal to a times the natural log of x plus b, the y-intercept. Now you see here we've got our data. I got x values running from 1 consecutively out to 8. And then my y values are 5, 7.1, 8.3, 8.3, 9.5, 9.8, 10.4, 10.8, and 11.2. So we're going to graph this first and look at this logarithmic model. Then we'll go in and linearize the data. We're going to do that by taking the natural log of the x values. We're going to get us a linear regression equation, and then we're going to take that linear regression equation and transform it into a logarithmic function. Are you ready? Are you ready? Are you ready? Ready? Now you can see here that I've already graphed the data for our logarithmic model in L1 and L2. L1 represents the x values, L2 represents the y values we've been given. But I'm going to prepare this to linearize this logarithmic model. And I've highlighted L3. And what I want to do is I want to take the natural log of L1, which is my x value. I'll close that parentheses and let's hit enter. And Shazam. Okay, so it's taking the natural log of 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's see. Now, I wanted to graph this, but I better get in here to my stat plot. And it's on, but remember, my x value now has become L. Well, no, let's just do it. Let's do L1 and L2 first. Let me change that L3 to L2. Better go in here to y equal because I bet I got an equation in there. I do. Let me clear it out. All right, so we're going to just take a peek at our scatter plot of the original data. So I'm going to hit zoom stat. And you can see it's kind of got the characteristics there of a logarithmic function. It starts accelerating up and then it begins to level off a bit. Now I'm going to go back. I'm going to go back into my stat plot. And I'm going to use the linearized data, which means I'm going to use the data from L3 as my x values. That's the natural log of x. I'm going to hit second L3. And my y value is going to stay L2, so that's all good. And again, I'm going to hit zoom stat, look at my data. And you can see it's pretty much a line. I'm not asked to do this, but I'm going to go ahead and go into y equals, and I'm going to hit vars. I'm going to go to statistics. Oh, I got to get my regression equation first. Excuse me. I'm going to quit out of here. Let's go back to stat. Let's go to calc. We're going to choose linear regression option 4. And let's see, my x list, I got to change that to L3. And my y list, from whatever I'd done previously, I need to get back to L2. Okay, L3, L2, x list is in L3, y list is in L2. Let's enter through here and let's get our regression equation. And if I'm rounding that, then I've got, we could say that it is 3x plus 5, substituting in, rounding up the 2.987 to 3, and the 5.05, let's say just to 5. And that could be my linear equation. And just for the fun of it, I'm going into y equals. I'm going to hit vars. I'm going to choose statistics. I'm going to say give me this regression equation. Let's see how this thing graphs. That's pretty good. So most of my data is sitting there on the line, so we have now linearized it. Okay, now we're going to transform that data back to a logarithmic function. So let's move on. All right, so let's see. Use a linear model for the transformed data to find a model for the original data. And our original data was in a logarithmic model. So our linearized model is y equals 3 times the linearization of the value of x plus 5. And if I'm going to put that into a logarithmic model, then it would be L equals A times the natural log of x plus 5. Let's see. We could use and that actually should read. Well, let's put that in that linearized form first. Not linearized, logarithmic form. So then we could say that we got 3 times the ln of x plus 5. But we could use our power property with that coefficient of 3 and then state this as the natural log of x cubed plus 5. Boom. There we go. And I think probably what I should have done is substituted here. That should have been b. And b is our y-intercept, and in our linearized data, the y-intercept is at 5 plus 5. So shazam, there we go. We have taken a logarithmic function. The data that certainly would appear to be a logarithmic function, we linearized that data. We got us a linear regression model. Then we use that model to transform it back to a logarithmic function for our data. I don't know what to say. I'm overwhelmed.